Hi, good afternoon. Thank you very much for attending this talk. I truly appreciate you taking your time to come and listen to this topic. Also, thank you very much to Grim and to GRIMMCon and all the folks who worked real hard to put this together. Uh, Thank you very much for inviting me. It's truly an honor, and I know it's a lot of hard work and dedication to bring together all these knowledgeable speakers, and I truly appreciate all the work that you do. Where this idea came from. I really wanted to develop something like Process Hacker, like the Process Hacker application for Windows, but I wanted to do it on the Mac OS side. And I know there's applications out there for Mac OS that dig into processes, like Patrick Wardlow's Process Monitor, but I really can't find anything that's quite like Process Hacker on the Windows side for the Mac, where it's graphical and very interactive. You can click on a running process and dig into the threads that are within that process and get tons of detail on all of the processes. It's also really cool to see everything in a organized tree, and you can organize things how you want, move it around. My problem there is that my experience in developing graphical user interfaces really lie in web technologies, right? And I don't have much there either, honestly. I mostly cheat and use Bootstrap for all my CSS work. So having said that, my colleague on the Zoom Red team, Chris Ross, he suggested that I check out Electron, with the caveat that, he wasn't sure how Electron handled the Mac OS native API calls that I would definitely need to access the OS processes. I didn't know much about Electron. I mean, I've heard of Electron. So I took a look, and I was actually pretty amazed by all the applications that are using the technology. I really had no idea. And I'll talk about some of those later. But through this development research, I found a way to make those API calls, to my surprise. And I also realized later, beyond this development application, the potential that being able to make Objective-C API calls from an Electron application has for red team operations. I'm a red teamer, so it was like, oh wow, actually, there's some cool stuff I could probably do with this on red team operations. So that's what this talk's about: electronifying your Objective-C and stashing Objective-C API calls in your Electron apps. So who am I? I'm Antonio Piazza. I am an offensive security engineer on the Zoom Red team. I live in Austin, Texas. I'm a father, I'm a husband, retired U.S. Army Iraq War veteran, and I was a 35 Mike human intelligence collector. What that means is I actually was an interrogator in Iraq, and I did debriefing in Europe. The agenda, I kind of want to start down in some introductory, topics for people who aren't familiar with all of the stuff that I'm going to talk about here. They'll need this introductory to kind of get to where I'm going with this talk. Some of you might already have or might be familiar with Electron apps and the Mythic C2 framework and AFL payload, osascript, and JXA, but I want to go through these topics before I get into actually the meat and potatoes of this, and that's making Objective-C API calls from your Electron app. So let's start with what is Electron. So it's an open source cross-platform JavaScript framework, and it combines Node.js and the Chromium browser. So the Chromium browser is kind of like your platform for your graphical user interface. It's really cool technology. Doing some research in this, again, I was kind of shocked by all of the applications that are built on Electron, from Slack to Discord to Twitch, and even Facebook Messenger that I don't have on here, but there's many more. Next, I want to talk about the Mythic C2 framework. So it's a command and control framework, open source, cross-platform, post-exploit exploitation red teaming framework. So for those of you that are not into red teaming and might not know too much about command and control, this is the server that I have up in the cloud or on-prem as a red teamer, where I will actually send commands to a victim endpoint that I I might have been able to compromise with an exploit. And exploit being one of these payloads that works with Mythic. And the really cool thing about Mythic is that it's modular. You know, you can build your own payloads to work with Mythic. There's a lot of documentation that can tell you how to begin building those. And then there's quite a few already built payloads for you. And anyway, the Mythic C2 framework is super powerful. I use it quite often in red team operations since I've really been working in Mac environments for a while. It has been my go-to C2 framework. It's created by Cody Thomas, really talented developer for Spectre Ops. He goes by It's a Feature on Twitter. So a little bit about the payloads that you have. You have Atlas, which is a Windows C#.NET payload. You have Leviathan, which is a Chrome browser extension payload, and that was actually developed by my colleague on the Zoom Red team, Chris Ross, I talked about earlier. He goes by Zorier. He was formerly of Spectre Ops as well. There's the Apollo payload, which is a Windows C#.NET payload. There's two Mac OS payloads. There's Poseidon, which does Objective-C calls, but is written in Golang. That one is created by my colleague, Chris Ross as well. And then, of course, there's the eval payload, and that's the one that we'll kind of talk about a little bit more in this talk. So yeah, the eval payload. It's written in JavaScript for automation, JXA. We'll talk a little bit more about that in the next slide. But it can be executed by Lolbin, living off the land binary, which is osascript, which we'll talk about here shortly as well. And it uses Objective-C API calls. It also supports download cradles, which is really cool. Means that you can actually, write a line of one-liner of osascript that will reach out to, wherever you're hosting a malicious payload, pull it down and execute it all in one line. Eval is limited by JXA language, and I'll talk a little bit about what I mean with that. JXA is really powerful, but it has some limitations and it has some things that are really painful. But overall, it's really worth digging into if you're going to be doing any Mac OS red teaming. Okay, osascript. So OSA is the open source architecture. It's native Mac OS, and it was initially designed for the use with AppleScript, but it will work with any OSA language. You can actually, let me get my laser pointer here. You can actually run this OSA lang command, and it will show you the OSA languages that are installed on the Mac, one of them being JavaScript, which is JXA, just talked about. And you can, osascript can execute scripts written plain text in the terminal, or also compiled scripts. And there's an example of that here. osascript tac-e, which is the execute flag, and then you can tell it's something like say hello world. That's actually an AppleScript command that will have your Mac use the Apple voice to actually speak hello world through your speakers. Or again, you can do a compiled script, run a compiled script with osascript, and it's got the .scpt suffix, .script suffix at the end of a file name. JavaScript for automation. JavaScript for automation, again, super powerful. It can control applications and Mac OS using JavaScript, which is pretty crazy when you think about it. You can use a web language to actually communicate with the operating system on a Mac. It's kind of like PowerShell less than version 1, and it can send Apple events to applications, local or remote. And Apple events are actually AppleScript commands and their parameters, and it's an IPC mechanism, right? So interprocess communication. So all of your macOS applications have the ability to send Apple events to other applications and receive Apple events from other applications. And you can actually take a look at those for any program that you want by looking at the script editor in macOS. JXA is invoked via osascript, among other ways. And you can do that with, again, with text on the terminal, with a JavaScript file, or using the REPL interpreter. And I show an example here. The REPL interpreter, you simply just in the terminal, type osascript tag L for language, and then specify JavaScript, and then tag I for interactive, and then you're going to get this prompt. This is just, same thing that would happen, if you typed in Python on the command line, you would get the REPL interpreter, and you could type Python commands. In this case, you could just type JavaScript commands, name variables, whatever you want, however which you would normally do in a JavaScript file. And then, of course, you got the JavaScript files you can execute from osascript, and you just give, you don't need any sort of flags. You just file name with the .js suffix, and it knows that it's going to execute a JavaScript file. And then, of course, the other way is you can do the tag L for language and specify JavaScript, and then a file with, .txt for the suffix. So you can if you have a text file that has JavaScript in it, you can execute that using, by specifying JavaScript as the language. And then finally, you have this the terminal text, command line text, where osascript for the command, tag L for the language, which specify JavaScript, and then tag E for execute. And then in quotes, you actually can, a one-liner of JavaScript separated by semicolons, and have it again say, just like we did in the last example, hello world. So yeah, that's the the AppleScript version versus the JavaScript version, a little longer in the JavaScript version. One of the things I want to draw attention to is this app.include standard additions. You're going to need to use this include standard additions equals true to access some of the things that, for JavaScript to access some of the things that AppleScript would access. Quick note, you can actually send Apple events remotely using remote IPC, and that happens with this EPPC protocol. It was like a needle in a haystack for me to find out what EPPC stood for. I found like one document on the whole web, and it I think according to this one document, it stands for event program to program communication. So I'll go with that. And it communicates over port 3031 or 3031. I'm not going to get too much into the remote IPC. Just note that it's communicating Apple events from one host to another, and over the network. And I actually have another talk on macOS lateral movement where I describe using AppleScript as a lateral movement tactic. And finally, the JXA cookbook is pretty much the most inclusive document there is for JXA. It's pretty big, got a lot of stuff in there. Highly recommend digging into that, and you could really get into the meat and potatoes of JXA with that. There's some stuff that's not there, but it is what it is. JXA is one of those things that Apple started to develop at one point and then just stopped. And of course, Apple themselves do not have very much documentation, so this is kind of a GitHub repository where some knowledgeable people decided to share what they know about JXA. The JXA and Objective-C bridge, this is really the power behind JXA, is this Objective-C bridge. This is how JXA JavaScript is able to actually make Objective-C API calls. Most API call, Objective-C API calls can be called from it. Some cannot. But you have to convert your Objective-C naming to JXA naming, right? Like you can't just call JavaScript and expect it to make an Objective-C call. You have to do some conversion there. And you have this obj-C object. This deals with the bridge and how the JavaScript engine actually accesses and interprets Objective-C objects. So you need this bridge for the JavaScript engine to actually be able to interpret and access Objective-C. And then you got this this $sign object, and this is the access point for all Objective-C functions. The JXA cookbook actually has a cool analogy for how the $sign object and the obj-C objects work together, and in that the Objective-C object builds the bridges, which the $sign object uses to walk across. So down here in this example, well, first we have to import a framework that we want to use. So if there's a function or an object inside our framework, we have to import it, and we're going to use the $sign. Again, that's kind of the access, or the we're walking across this Objective-C bridge that we're building to the import, or using this import function, and we're grabbing the Cocoa framework. Down here, we're defining a variable, and we're calling this host. And we got this NS host object, which comes from the Cocoa framework. And we're using this $sign object again to kind of walk across the Objective-C bridge that we built to this object. And then we have the current host function from the NS host object that we ultimately want to call. So finally, in order for us to kind of see the results of a Objective-C, JXA Objective-C bridge function call, we actually have to unwrap the object. So again, we have this Objective-C or Object-C bridge, and we're bringing this back to this deep unwrap function, and we're getting that host addresses variable from the current host function that we called here. So host.addresses. So this host variable, and then we want to see the addresses. In order to see that in JavaScript, we have to use an unwrap function. So we have deep unwrap, and there's also an unwrap function that I'm not going to get into, but you get the idea. So Objective-C and Electron apps. So taking all this and all this. So far, we know what osascript is now. We know what JXA is now. We know what an Electron app is now. How do we put all this together? We want to be able to somehow use JavaScript to make Objective-C calls from our Electron app. Well, I mean, we don't have JXA, per se in our Electron app. We do have JavaScript, but we need to be able to somehow specifically use JXA in our Electron app. And the way we can do that, this is what I discovered, since Electron uses Node.js, one can use osascript in Electron, and you do that because there's actually a npm called osascript by Mikhail Brevik. So I did a lot of searching and found this, and I was like, oh my God, this is what I need. So we use osascript and thus JXA with Node.js. To do that, I'm going to go through, through a few steps here. I'm not going to get too detailed because I don't, because of time constraints. You first are going to need to install Node.js, and then Electron. Before you install Electron, there's actually something that you need to do. There's a weird issue, and you have to give write permissions to the node _ modules directory to all users. So as you can see in this example, I'm doing this. I'm giving permissions to all the users for this node modules directory. That's going to allow us to install Electron globally, and then you can see I do that here from npm with the tag G for global, and I get the at latest version here. And then you're going to have to initialize the Electron project using npm init. And then finally here, this is where you're going to install the osascript module into your project directory, and that's use npm install osascript save. Again, I don't want to go through in all these details, but I do have a detailed step-by-step instructions and tutorial on how to do everything I'm talking about in this talk. And with some support files as well, tutorial files on my Medium blog, which you can find here. And I'll actually have the links for a lot of things at the end of this presentation and share them as well. And this is an example of the Objective-C bridge in a JavaScript file being utilized. So the first thing here that happens is you're going to define a variable. We're just going to call this osascript. You're going to use this require function. And again, this is a JavaScript file inside your Electron app. And we have the argument in quotes osascript that's saying, hey, we want, telling Node that we want to use the osascript module that we have saved in our project. So this eval function in the osascript module allows you to use JavaScript commands basically written directly as text. So we'll talk about the other way that you can use it next, but in this particular example, we're using eval, and then we create this script variable where we're putting this text, and you'll notice this is the same. This is a one-liner from the last example for basically getting the host addresses from a system. And then you're going to use the osascript function from the osascript module, and you're going to call as your argument the script variable. The rest of this here, it's in my tutorial files too, but this is just a way for you to get the data back to your browser console, and then get errors back if there's errors. So yeah, the same command, but a one-liner in the terminal would look like this. So running the osascript command, tac L for language, and then specifying JavaScript, tac E for execute, and then here's again the JavaScript lines separated by semicolons, and again you're going to get you're going to return the addresses of the host machine that you're on. So how do we weaponize this? This is why the app-fel payload and the Mythic C2 were important to talk about at the beginning of this, because again, this is the framework that I use quite a bit in red team operations. This is kind of like the proof of concept of how you can actually use an Electron app on a red team exercise. So you can actually create a JavaScript file that holds the app-fel payload, and the app-fel payload is just a JavaScript file, and embed that into your into the directory in your Electron app as you're developing it. The way you do this, and again, we talked about using this .eval function in the last example. This time, you're going to use the .file function. So instead of being able to run a one-liner in a variable, you're going to actually call a JavaScript file that you have embedded in your project. So in this case, we're saying we have @fel_payload.js. So the osascript function is going to call that as an argument. Again, this .file instead of eval, and all the same feedback into the console here and errors. You could probably, if you wanted to, take the whole app-fel payload maybe and separate it by semicolons and use the .eval function for that, but that's really long. So that's kind of the reason why I would use this .file and embed the file into my my Electron app directory. I mean, that would just be a mess, and it's much easier just to have a JavaScript file that has .file payload. And again, it's super long. The other thing that we could do, though, is we could go back and use the eval function, and we could actually we could have our app call a JXA download cradle. and you can download and execute the hosted app-file payload or some other JXA file with a one-liner. And this is the JXA download cradle. You could put this into this one-liner here into the that script variable that we had in the very first example, using the eval function in the osascript node module. And yeah, it's really simple. Just you put this in quotes. osascript tach L for the language, JavaScript, and then tach E to execute. And then you notice this eval function here. So what that eval function is going to do is it's actually going to not only download your malicious payload, but it's going to execute it. So all in one line, you're going to download, say you have an app file payload hosted on eval.com. It's going to download it here, and then this eval function is actually going to execute it. So yeah, pretty cool if you can sneak this into an Electron app, have the app do some other functionality that works with the pretext for your social engineering or your phishing campaign, and the victim runs the Electron application, sees the normal behavior that they're supposed to see, but in the background you actually have this osascript node module downloading an app file payload and executing it all in one shot. Some more ways to weaponize. After I had written my Medium article or my Medium blog post discussing all this, Atomic Shell I had shared it in a forum, and he had read it. And he had actually taken this and created an Electron Visual Studio Code extension and used it in a red team operation, according to him. So he was successful with that. So that's pretty cool. So to finish the story about creating the macOS process hacker application that I was talking about, and going beyond this red team use of Electron applications, or using JXA, the JXA Objective-C bridge in red team operations and Electron applications, I was trying to figure out how I could actually get into some of these, deep low-level processes from the Mac OS using JXA. And how I did that is actually there's a researcher, a Mac OS researcher, Jaron Bradley, who created a application called TrueTree, which really digs into the parent-child relationship with processes on a Mac OS. Apple would like you to believe that every process has one parent, but Jaron actually was able to dig in and show the true parent-child relationships, what the true parent of child processes are. And again, did that with TrueTree. He wrote that in Swift. So what I had to do is I had to take that and I had to convert the Swift into Objective-C first of all, and then I had to take the Objective-C APIs and again do that in JXA, and that would allow me to really dig in these macOS processes. I was able to get pretty far with that. I was able to use a really cool JXA feature that I think I might have just touched on, and that is binding functions. So you can use C libraries and even dynamic libraries, dylibs as well. Use the bind function to tell JXA how to call those other functions, those C functions or those dylib functions. And then you need to get a handle on the dylib. So there's an example here. So libproc is the C library that I wanted to access the functions of, and in order to do that on the Mac OS, I couldn't find the C library, but I did find this libproc dylib, so I was able to actually access that. And so here I variable, and I create this variable libproc path that goes here where this dylib actually is on the Mac OS system. I need to get a handle, like I said, on the dylib itself. So here I create a variable and a libproc handle, and I use this DL open function and give it the parameter of this libproc path, and that's how I open that dynamic library. This DL open. Actually, I don't show it in this code, but I had to actually bind that function as well. So after it's bound, you see I can just use the dollar object, a $sign object again to walk across the Objective-C bridge to access the DL open function. After I get a handle on the dilib, I have to get a handle on the function that I want to use inside of that dilib. So in this case, it's proc list all apps. You can see here, I have to use the DL sim to actually get a handle on that function. So here the first parameter is the libproc handle, which is here the handle to the libproc dilib, and then the actual function that I want the handle on, which is proc_list all PIDs. That's going to give me a list of all the process IDs. Finally, I need to bind the function proc_list all PIDs from the libproc dynamic library in order for me to call it with that $sign. Walk across that Objective-C bridge. So here I got the Object-C object and then the bind function, and I'm telling it this is where that signature comes into play. The function signature from the libproc dilib for proc_list all PIDs has to be exactly how it's written in the source code. So in the source code, the return value is going to be integer. One parameter is this void, and then the other one is an integer. So this is exactly how you'll see this proc_list all PIDs function defined in the libproc C library. So yeah, this really allowed me to dig into the OS processes, but I got stuck. But I really did. I found some really cool stuff. My team can do on red team operations, but I was unable to complete what the original task was, at least up to right now. And the reason is that the most important function that I need from the libproc C library is or in this case, from libproc dilib, is the function PIDinfo. And the reason I really can't use that or haven't figured out a way to use that is that it has a required argument that is a pointer to a specific C struct, which is proc_bsd info. So I found that JXA does not have an easy way to do this. And in fact, there might not be a way at all. I'm not sure. I haven't been able to find it, and nobody's been able to that I've talked to so far. Desperate times call for desperate measures. I called on my old friend Stack Overflow, and I have had exactly 0 responses from my question. So please, I beg of you, if you happen to be one of the only other people besides me in the world that seem to have a Stack Overflow account today, please go and upvote my question. Click this little up arrow. I would greatly appreciate it. And if you can answer this question, please, for the love of everything good in this world, I would really kind of remove that roadblock that I have, and I would love to talk to you and collaborate with you on helping me finish this project. Would be amazing. So that's it. I want to thank you all again so much for taking the time to come and listen to this talk. I really hope you took something from it. I hope you were able to, if you hadn't heard anything about osascript or JXA, took something from that, or if you had, really got to what the meat of this talk was about, using Objective-C calls in your Electron apps. I really hope that you took something from that. And again, thank you so much from Grim and everyone at GRIMMCon for putting on this convention and for inviting me to speak. Here's a list of all the references for everything that I talked about in this. thank you all so much, and I'll be here on Discord for any questions that you have, and enjoy the rest of the conference.